Hello. Um, do you hear me? You see me? Cool. Right. So today we have another lecture. I start where we stopped last time, and the plan is like this. So first, I'll remind you about resource description framework, general remarks. Then we'll discuss answers to the questions. We started discussing them last time, but didn't finish. And then we'll start looking at the query language for the RDF data model. So this is the plan. Maybe I'll have to stop 5 minutes before the usual time. Okay, RDF. Yeah, all the slides, answers to the exercises are on the web page. So everything should be available. Okay, so we are considering the RDF data model, resource description framework. This is, for many of you, probably it's a new type of language, new way of describing data. In fact, it is conceptually similar to entity relationship or class diagram, UML class diagrams, yeah, where you similarly represent information in a graphical form. Okay. Now, the whole idea of RDF is based on a simple observation that to express statements about resources, and resources is what we deal with in semantic technologies, so all such statements can be done as triples, can be represented in the form subject, predicate, object. Yeah, that's it. Resources, what is a resource? A resource must be identified by a URI. That's it. Otherwise, we don't care what is inside. There must be a URI. That's a resource. So a triple, every triple consists of three things: subject, predicate, and object. Now, the subject, the first component, is either a resource or a blank node. Yeah, that is either a URI or a URI isn't given, and we write some special things like underscore column to, I don't know, X, to indicate that this is a blank node. The predicate, the second component, must always be a resource. It cannot be a blank node. The object, the last component in the triple, it can be one of three: a resource, a URI, a blank node, and finally a literal, yeah, a string of characters in quotation marks, like a name. Okay. So objects of triples can be literal, while subjects and predicates cannot be literal. Yeah, remember this. Literals can be plain, or they can have a language tag. Yeah, for example, we can have this triple in the turtle syntax. Yeah, remember that we have a syntax which is called turtle for ters, whatever triple language. Yeah, and triples are represented like this. And the first component, the first element of the triple is geo : Berlin. Yeah, this is supposed to be a URI. Yeah, and the beginning of URI is given in this namespace geo. All right, somewhere it's written that geo is in fact a URI, some long sequence of characters. Okay, so geoname is the predicate here, which we call property. And Berlin, in quotation marks, is a literal, a string of characters. Yeah, and we end each triple with a dot. Well, unless we try to shorten our triples, we'll see how. Okay, so this is without a language tag, and these two are triples with language tag. For example, yeah, I want to write that Germany, this resource, has name Deutschland in Deutsch, and it has name Germany in English. Yeah, then I use this language tags. There are many other little things. I wanted to show that I'm not going to discuss all the intricacies of the RDF language. Just wanted to indicate that something is there. Now we can also tell the computer that certain literals have a certain data type. For example, here, Berlin has population, and then there is a string of characters which should be interpreted by the machine as an integer. Yeah, so here I use the XML data type XSD integer. Okay, so there are plenty of tutorials with examples. Here are 2 links. What else did I want to say? Blank nodes. Blank nodes are anonymous resources, yeah, where for whatever reasons we either don't want to give a proper URI, or it doesn't exist, or for some reasons there shouldn't be probably any proper URI. Yeah, for example, we can collect information about, like a bag, about something. Yeah, for example, here we have this blank node, and it collects the following information. So this is _x. It says that this is of type. Yeah, A. Remember that A means type, means RDF type. RDF type. Type city. Here contained, it's a property contained in here resource Germany, and has name Berlin. Yeah, simply here under this blank node, we collect some data, information about Berlin. Well, and alternatively, you can give a URI, say an official URL of Berlin, and so on. All right, so next I wanted to discuss the SPARQL query language over data given in RDF, but before that, let's look at the exercises. So there was exercise 1 about, I gave you a turtle document, and here is its content in English. Then we considered another exercise, how to represent knowledge about a journal article. So now we move to exercise 3, where I ask you or myself to represent a sentence or sentences in English as RDF triples. That is, I have to design myself a vocabulary and write triples. Okay, so the answers are there. Yeah, let's discuss, because some are not completely trivial. All right, let's have a look at this number one. Yeah, what's written? Books and articles in journals are publications. Yeah, what considerations can we have here? So what is a book? What is a journal? Aha, I see here that I don't know, Dostoevsky Idiot is a book. Tolstoy War and Peace is a book. Right, so this probably means that book is a class. Right? Book is a class. Or alternatively, you may argue that, okay, in this or that particular situations, it's preferable to represent a book as a resource, not a class, as a an individual. Maybe, but I argue that it should probably be a class. All right, then what I write, and then journals, yeah. Books and articles in journals are publications. Then journal article should also be a class. And what we have to say that in mathematics we would have written like book subset of publication. Yeah, and journal article is also a publication. Here we write the following RDFS triples. We use this built-in property subset of, and it's written RDFS. It's a property which is defined, is given in RDFS. Okay, so then these two statements, RDFS statements, belong or are part of RDFS. Fine. Number two. Authors of books and articles are persons. Right, it's also about some general things. Yeah, probably what we need is a person. What is a person? It's a class, yeah? There can be one person, John, another person, Mary, and so on. All right, so we have person, then what? Authors of books and articles. Authors, and how to model this? Yeah, say I have a book. Yeah, so this is a book. This is an element of class book. And then what? And then how to connect it to the author? Yeah, we need a relation. Yeah, and it will be, I don't know, authored by, or how I write here, is written by. Is written by. By whom? By some guy or girl or grandmother. And this is a person. Yeah, this is these are persons. This is what I want to say. What do I want to say? Authors of books and articles are persons. That is, authors are some here. Yeah, that is at the end of is written by an author. So what I want to say that the end of is written by, the end means range. I want to say that the range of written by is a person, is a subset of person. All right, this is what I write. Is written by is a resource. All right, and we have this property range. the end of the range of written by is, and here I use FOR, friend of a friend vocabulary, yeah, which is about people. In particular, there is a class person there. All right. Now, important here, all authors are persons. Not only of books and articles. Yeah, whatever is written by, a letter is written by a person, because I can say just about the whole written by. Whatever is written by, it is written by a person. Okay, how about this one? Number 3. What can be written by an author is a publication. What I want to say is that the left-hand side, here, this left-hand side, the first component, if I have X is written by Y, then Y is a person, Y is a person, and X is an, what's written here? Publication. All right, then what I want to say is that the domain, the left-hand side of is written by, is a publication. Is written by RDFS domain publication. All right. So what is next? Now it's harder. Let's read. Publications with ISBN are books. I forgot what is that. International Standard Book Number. Publications with ISSN are journals. I don't know what is ISSN. Google it. International Standard, I don't know what. But what I know is that ISBNs are books, ISSNs are journals. Right. How to model it? How to model it? Now here we are in trouble in some sense. How to model it? Say, what I have a concrete book. I don't know, B1. Right. I open the book. I have a look. Oh, here it is. ISBN. So I write here B1. I don't know. Has number. Has number. Yeah, and here I write whatever, ISBN 53. Okay, but how can I say that this is a book? Or how can I say that this is a book? Yeah, what I want to say, that if here I have ISBN, then here I must have a book. RDF does not allow us to do this. That's a very important thing. We can't model this. It's called local scopes of properties. This can't be done. What we can say, we should model the situation differently. Instead of say has number, it makes sense to write, for example, has ISBN. That is, the fact that it has ISBN is written already in the, is given by the property. Yeah, and another one is, say, A2, and here it will be has ISSN, and then ISSN 1, 2, 3. And if I write like this, then I can say that the domain here, the domain of has ISBN is a book, then this will be book and the domain of has ISSN is a journal. So this will be journal. Yeah, so we cannot have a single property has number, has number, and depending on whether it's ISBN or ISSN, decide whether the subject is a book or journal. It can't work, yeah, because we cannot, in this language, we can't distinguish what is at the end of has number. So in this case, we use two different properties, has ISBN and has ISSN. All right, another thing, number 5, publications and authors are different things. Or in other words, publications, class publication and the class author do not intersect. No way to express this in RDF or RDFS. RDF and RDFS can say only positive things. Yeah, never negative. So we can't represent disjointness in RDFS. All right, now something else. Now statements about statements. Yeah, look at the at this one, number 6. John believes that Mary wants to marry him. Right, it's a tough one. Not only that John is a poor guy, but just the structure is quite sophisticated. Yeah, so the idea when you represent statements about statements like this, then you do what is known in computer science as a reification. Yeah, roughly reification means that we replace, say, here a statement, Mary wants to marry him. Yeah, we represent it as a resource, as a blank node. Yeah, say X. And then we say, John believes that X is true. And what is X? X is Mary wants to marry John. Oh, sorry, Mary wants to marry him. Sorry, let me disassemble it further. Mary wants Y. Okay, Mary wants Y. And Y, what is Y? Mary marries John. All right, so John believes X, and X is Mary wants Y, and Y is Mary marries John. Yeah, as soon as I've verified, I replace this two statements in terms of simpler ones. Yeah, I can write the following triples. So John believes X. Okay, let me draw it like this. This is John. Then John believes. Okay, believes is believes X. Sorry, believes X. X is type statement. And the subject is Mary. Object is Y, and predicate is wants. Yeah, wants. Now, so John believes is a statement that Mary wants Y. Y again is described in a similar manner, like this. Y is of type statement, subject Mary, predicate Mary's, object John. Okay, here is another example, number 7. It's pretty similar, but I write it in a different syntax. Instead of underscore and colon, I use square brackets. Yeah, John believes that Mary is at home. Yeah, so this is X. John believes X. And instead of X, instead of blank note X, I use this square bracket. When I begin a square bracket here and end it there, this means that it's like this situation. Yeah, like I introduce a blank note X of type statement, subject Mary, predicate has location, object home. Okay, statements about statements require constructions like this, either with explicit blank notes, like here, or using square brackets. Okay, let's move on. I have 3 more examples. They are about a different thing. They are okay. Let's read. Star Trek. And what is this? Jim T. Kirk is a person whose name is Kirk. First name is James. Middle name is Tiberius. Home planet is Terra. And who is the captain of Enterprise. Right. So how to model it? So we are talking about somebody who is Jim T. Kirk. Okay, let's introduce a URI for this. Yeah, okay, so this will be my URI, Jim T. Kirk. That will be my URI. And then what do I want to say about that? It's Jim T. Kirk is a person, all right. Remember, we have already used person, yeah, of type person. Yeah, we can use person from FOAF, or I can use it from my own vocabulary, not that important. Whose name is Kirk. Right. Again, I can use some property from FOAF or other places, or here for simplicity, I invent myself, my own. So his name, and here is a literal, yeah, Kirk. Then has first name, and this is what James, yeah, and then middle name is Tiberius. Okay, it's easy. It's easy. Home planet, fine. I just introduce a property has home planet and a URI for Earth, Terra. And yeah, I introduce a property is captain of Enterprise. That's easy. These are just more or less straightforward triples. Let's wait. There will be a more complex example that involves Jim T. Kirk. All right, another one, number 9, is pretty similar. Spock is a person whose name is Spock. home planet Vulcan, and who is a crew member of Enterprise. All right, similarly, I introduce a URI for Spock. Spock is of time person. Spock has name Spock, yeah, as a literal, has home planet Vulcan, and is crew member of Enterprise. No problem. How about the last one? The last one says something about Enterprise. Enterprise is Starship. That's good. So I introduce a URI for Enterprise. Actually, I have one already. It's here. Here I have a URI for Enterprise. And so I simply write that Enterprise is of type Starship. Enterprise is a Starship. So Enterprise is of type Starship. There may be other starships, and for them we'll also write URI type Starship. Okay, whose name is USS Enterprise, da da da. Fine, no problem. Use has name. Enterprise has name and this literal. Enterprise has 430 crew members. Okay, this is here. And what's important is that the machine knows that this is an integer. Yeah, so I just say that this literal is an integer. Not a problem. Enterprise was launched in this year. Okay, same way. But now, oops, it's written here that had Christopher Pike as captain from this year to that year. Oh, I made a typo here. Let's consider this. Let's assume first that it's not Christopher Pike. Yeah, assume that it's a what was his name? James T. Kirk. James T. Kirk. Right, so I want to say that James T. Kirk was the captain of Enterprise from this year till this year. I'm sorry, what is the main objective of this RDFS? Please, I explained this last time and before that. Right? It's resource description framework. It is how to represent data, for example, on the web, so that other computer agents could query this data. Okay, and the query language will be considered today. Have I answered? Oh, do you have Google? Google it. So I'll show you a concrete example when we learn the query language. Otherwise, how can you use data if not through queries? Google like Sparkle endpoint. Yeah, then Sparkle, sorry, it's Sparkle. Yeah, then you'll be offered a window where you can write your queries and the data will be represented as RDF. Libraries represent their data as RDF. Hospitals represent their data as RDF. Governments represent their data as RDF. It's way simpler. It's accessible for general public. And unlike database format, everybody can query this data because you don't have to know the structure of databases. Here, everything is a triple. That's the whole idea. The data is freely given on the web for everybody's access. Wikipedia has an RDF representation called DBpedia, and so on and so forth. Okay, so instead of English or any other language, data is represented, must be represented in a formal language. Yeah, there are different ways. We considered XML, and we saw that XML isn't proper. Yeah, it represents only 3 structured information. There are database query languages, but their users have to know the schema, the meaning of the tables. We'll look at this next time. In the RDF representation, everything is a triple. You can read and understand the schema using your queries. Okay. What is the problem here? Whatever way, even if you represent the data in a proper database, how to represent the following thing. Somebody was a captain between this year and that year. How to model it? What would you do? Yeah, you develop a database, and here we just wrote that James T. Kirk is captain of Enterprise. Right? It's just a statement. But in this example, number 10, actually the statement is more restricted. Yeah, James T. Kirk was captain between this year and that year. So we have to represent something which is an event which happened in time. How to model it. And this is the model I suggest. There are some special agreements about this, but what I want you to just understand that here I'm thinking of that Enterprise has captain between this year and that year, and this particular captain as an event. Yeah, so I introduce a blank node. Yeah, and I write that this type is an event, and this event has what? Has kind of the subject, who was the captain, James T. Kirk, and the start year of the event and the end year of the event. And so this is one way of modeling. Okay. Let me now move to the query language. So databases, relational databases, have their own query languages, say SQL. All right, here we have a different type of data representation, RDF, and for this case we need a special query language. How can we ask a system to find answers to our queries? All right, so the language is called Sparkle. It's not like SQL, not Sparkle QL. The authors claim that it should be pronounced as Sparkle. It's a W3C standard language recommendation. There are already at least 2 versions of this language. First, I want to explain you the idea using a simple example. Right? Actually, I'll explain you the language using examples only. So let's consider this database. Right, this database contains some information about books. Right, what do we have here? We have a library, which is has location Bremen, and then let's look at what's written here. There is a URI JLB. JLB has name Jorge Luis Borges. Okay, and then some B1 has author JLB. And this B1 has also title Labyrinths. Okay, right. Then there is a book B2. It has author, the same JLB, and the title is Dr. Brody's report. B3, also JLB, title, some title. Okay, so what happens? We have a URI of an author. The name is the name, and then a URI of a book refers to the author, the title, and that's it. And like this about many other people. Yeah, this is a typical representation. You can add here date of publication, all the information, publisher, and so on. All information, possible information about books. Right? How to query things like this. Now, remember that we can represent triples like this. A triple is a very good data structure. Begin, end, and arrow. Right? So we can draw a graph. Say JLB name has name. And here is a literal. Okay, then we have B1, it's a book, and author, JLB, and title, Labyrinth. Okay, now we have B2. B2 has author JLB and title whatever, doctor. Right, and you can draw a picture like this. So it will be a graph, and the graph is directed. Yeah, a beautiful data structure for any mathematician or computer scientist. All right, and suppose next I want to find the names of authors in my document. Names of authors. Names of authors. Yeah, how would you find names of authors? Names of authors. Aha, look. How about the following? So what I need, so this is author, this is name. Right, so what I have to do, I have to look for patterns like this. And I have to return this value. And this one, I don't care. And about this one, I don't care. Right? And this is the whole idea of SPARQL. We give graph patterns to query. All right. Actually, no, what I said is even wrong, because we know that in this context, name simply means the author name. So probably I don't even need this one. Yeah, just this will be the pattern name in this context, because in our database, maybe there are no other names but authors' names. Okay, so a query, a SPARQL query is like this. There is, in the prefix, we refer to where we query, yeah, the data source. Then here we refer to the query variable, what I want to extract. And here I give a graph pattern, query pattern. So I want to extract, I want to find triples of this form. Some beginning, yeah, question mark X is a variable identifier. Yeah, it can be replaced by any subject. Then lib name, yeah, it's a concrete property. And question mark author is the third component of the triple. In this component, I want to return. This is the query variable. Okay, so I take this query pattern, go to the graph here, yeah, and so what was that? Name, yeah, so this will be X, then has name, and this will be, what was this, author. Yeah, and this value I return. That will be an answer. A different way of doing this is here. Yeah, my query pattern can be identified with this triple as well. Yeah, X is here, and the author will be returned, this Casares. And then another one, another name, yeah, Cortázar. And finally, there is another name. No, I don't see more names. So there are three answers. So there are three triples in the document that have the form of the query pattern, you know, that have this form. And these are the triples. So what the system does, it returns the values for the author. Yeah, assignments to author will be returned as a table like this. Right, so the idea is pretty simple. Yeah, we just give a pattern and say that in which we can use variables. Yeah, instead of subject, object, or property. Yeah, and identify certain answer variables, and these answer variables should be returned by the computer. This will be the answers. We can organize these answers in many ways. We'll see how later, but this is the whole point. This is how SPARQL is used to query RDF data. Okay, another example. Another example, find the names of authors and titles of their books. Names of authors, titles of their books. Right, let us go back to the document. Names and titles, names and titles. Okay, names and titles. Names. So we need this. This is a name. And this is the title. Yeah, so my graph pattern will be, this is the name, this is the title. The graph pattern is more complex here. I need name, author, and title. Okay, let's have a look. What do I have here? I want to return author and title. And what is the graph pattern? Some B is author of A. A has name, author, and return this. And B, title. In this title, we have to return. Okay, let's go back again. This one has name, and we return this name. Then this has author. Oops. And this has title, and we return this one. So we need 3 triples. One here, one there, and one there. And this 3 triples will be our query pattern. Okay, here it is. Now we have two answer variable, author and title. Author and title. Yeah, we want to return the names of authors and the titles of the books. All right. So now we'll have the answer. We have assignments to author and title, all possible. So we take this pattern and use it to match in all possible ways in the data. All right, and this will be a table of answers. Yeah, Borges, Labyrinth Borges, Dr. Brody, and so on. So variables can appear as subjects, predicates, and objects of RDF triples. Okay, one more example. Give the names of authors and also the places where they were born if this information is available. So names of authors and also the places where they were born. If this information is available, what do they ask us? Let's have a look. So let's have a look here. So we have name Cortázar. And then we have here the last triple, born in Brussels. However, say in the case of Borges, the place of birth isn't given. So how to return these two things? First, name is here. Born in is there. Right, so I may want to look for this pattern. However, I have to be careful because for some authors, their birthplace is given, for some not. No, this is not this one. In this case, the query will be like this. So I'm looking for author and birthplace. Yeah, and my pattern will be like this. Yeah, X has name author. I return author. And then I write optional and give another pattern. Yeah, this means that, and if this triple can be satisfied as well, return birthplace. If not, okay, then there is no information for this. So optional, and then this what is going to be returned. Borges, name of an author, no birthplace. Casares is a name, no birthplace, and Cortázar, birthplace Brussels. So here it is important. Yeah, because we use this optional keyword, optional construct, then when there is no values for this triple, then only the author will be returned. But if there is a value here, then this value will be returned as well. Yeah, say if I remove the word optional, if I remove it from here, then there'll be just a single answer: Julio Cortázar, Brussels. Yeah, which is maybe not too good. Okay, my next example. My next example is like this. I want to, but if we want, not to return authors without. Okay, so if I don't want, if I want to return only, say, how to remove this? Okay, remove optional. That's easy. What is the next example? The next example is this. So what's the situation here? There are two databases, and they are written in different languages. You say one contains triples written in the 4auth language. We have seen it already. And there is another vocabulary called vcard. And suppose that we have the following triples here. Yeah, say in 4auth we have Mark Jones and we have Sarah Jones. And yeah, and here the property is 4auth name. All right, and in vcard we have vcard : fn, probably for family name. So this is 4auth namespace. This is the vcard namespace. Okay, and I want to return all the names. I want to return all the people's names in these two databases for whatever reason. Yeah, what shall I do? Now, of course, it's easy. I can write question mark x 4auth name and return this. This will be the answer variable. Yeah, I need all of them. And then next I want to question mark x vcard fn name. Return this one. But I can't write just, I can't say that this is the pattern. It's not like this. It's, I want to return all values for this pattern and all values for that pattern. And for this, there is an operation, and it is called OR. This is an union. This is a keyword union here. Yeah, or I want to return name such that, okay, you see here, I use square brackets as a blank node. Yeah, it's the same as to use any question mark x. Now I don't. It's just a variable. Okay, so the important thing here is that the answer will be an assignment to this, and all assignments to this. That is why I take the union. Yeah, I have to match either this part of the union or this part of the union. Right, and the answers will be this: all Mike Jones, Sarah Jones, Becky Smith, and John Smith. Right. So here I emphasize that instead of square brackets, you could use question mark X. This is just all the same. One more construct. In this particular, so far all our queries returned a table with the assignments of the answer variables. Yeah, an answer is a table where answer variables get proper assignments. Now, if you don't, if you write select star, this means that all the variables you have in your query are answer variables. So return the values of all variables in the query. Now, another keyword, construct, returns a set of triples. Yeah, so you have some data in one format, and I want to convert this data in another format, or I want to extract from this data some smaller part in a certain format. So in this case, I use the construct. Yeah, for example, so what do we do here? Construct, I want to return all triples like this, where in this bit will be matched in the data in the RDF document. So all triples like this, plus filter regex author should begin with Julio. Right, what's the meaning? Aha, construct the corresponding, the fragment of the data, but only about Julio Cortázar. Yeah, so I want to have my little library with books written by Cortázar. So I can extract from a large database, I can extract these triples about this particular author. Okay. Yeah, and this will be the answer. So here I return not a table with their values, but I return triples. Yeah, so this is database transformation. Okay, now, what does the following query construct? Construct name of people with this URI. So there will be wait a second. So construct this. Oh, I want to translate vcard into FOAF. That's it. Sorry. I want to translate vcard FOAF into vcard, but with this URI. Yeah, and this is what is going to happen. If I had info of this information, then this information will be translated into a into the following vCard format. Transform, translate data from one form to another. Okay, I have some more examples. So what is here? Data. I have book 1. It has a title, Sparkle Tutorial. And this book has some price. And there was another book, and it has its own price. And what I want here, I want to get all the titles of books whose price is less than a certain value. Now, I don't want to buy expensive books. I want to buy only reasonably cheap books. Okay, probably I don't care about the what these books are about. No, I want to have their titles. Fine. Now, how to use it? We use again this keyword filter. And so I want to have what I want to return. I want to return title and price. Where is title? Title is here. Yeah, this triple says that give me the title, and this triple says give me the price. And filter says that only return these values only if the price is smaller than something. So this is a condition, and this condition must be satisfied. Filter. Okay, in this particular case, the answer will be the title, semantic web, price 23. Now, there are lots of filters, like in SQL. We can use logical and or not. We can use some arithmetic. And we can use a number of Sparkle tests. For example, we can check whether a variable is a URI, yeah, whether it's blank or not. Return all values. What do you mean when specifying X? In which context? In this particular, what do you mean? What do we mean when specifying X? Look at the triples here. Book 1 has title. Book 1 has price. Book 1 has title. Book 1 has price. Yeah, so the X here stands for here, for this node. Right? I don't need this node. What I need is titles of the books with this value. Right? So I don't want to return B1. This will be question mark. That's not an answer variable. This will be an answer variable, and this will be an answer variable for here. Okay, cool. Now, remember these little things here. These are very important. I can test whether the value of some X is a URI, for example, or whether it's blank, or whether it's a literal, or whether it's bound, that is, it received some value. We'll come back to this later. Now, this is a pretty complex example. Let's start looking at it and then return back to it. So here, the Sparkle query is pretty tough. Yeah, just imagine that you have a Wikipedia page, and this page is about cities in Texas. Yeah, and there is a lot of information, and what you are interested in is the following information. So return the URIs that identify cities in Texas, and also what I'm interested in their total population in descending order. Yeah, so first largest cities, then smaller cities. And for some reasons, because I do some research for some company, I want to return only those results that do not have a metro population. Do not have a metro population given on that website. Yeah, that is Moscow, but without Moscow region. I say if on that website the metro, the Moscow region isn't given, then I want it to be returned, yeah, for whatever reason. All right, now there are pages like this, say Wikipedia. Wikipedia is also represented in the RDF format, DBpedia. Yeah, so just think that we are, or your computer agent is querying DBpedia looking for this information. Yeah, and you don't need everything. You need only 10 first results. Yeah, that is 10 largest cities. All right, so here is the pattern. Let's see. City of type, and here I refer to DBpedia, class, cities and Texas. Yeah, I've checked DBpedia and I found triples like this. All right, and then population total, it will give total population, but I don't want to return this population together with the metro population. Yeah, I want to return it only when the metro population isn't given. How to say this? Look, this is the trick. Optional are city, population, metro, pop metro. I'm looking for this. And if there is a value, if this variable receives a value, I don't want to return it. I want to return only this pop total when this variable doesn't receive a value. So here what I write, filter not bound. That is, this variable has no value. Yeah, exclamation mark bound x means x, question mark x, has not yet received a value. Yeah, and then I write ordered by descending pop total. Yeah, that the results will be ordered by they'll be ordered in descending order, and limit 10, there'll be only 10 results returned. Okay, so I stop here. I don't understand the meaning. Bound question mark x is true if x has received a value. Okay, so what I do, I try to match this triple in the data. And suppose that city, I don't know, Texas, yeah, received a value. Pop Metro, suppose it receives a value, I don't know, 5 million. In this case, bound Pop Metro is true. It has a value, 5 million. The exclamation mark here says not. Yeah, that it must be false. Is it better? So not bound X is true if bound X is false. That is, X has no value. All right. So you want any other questions? Next time, my idea is that, okay, there are a few pages here, and then we'll consider concrete examples, right? And then I'll see whether we can do something with some real data available. I don't know, DBpedia, for example, to query DBpedia about movies and artists and this kind of things, or whatever. Yeah, this is the plan for the next time. We'll play a little bit with the Sparkle, with concrete data available on the web, and then move on. Okay, that's it, guys, for today. See you next week.